Howdy, AP PreCal. It is Ms. Kosh. This is totally beyond the scope of our AP course. So we're having fun in class today, figuring out how to go from a complex number in rectangular form to a complex number in polar form. But we didn't really understand why we cared, so we were going back and forth, and we're like, okay, now what? And I decided to make this extension because, one, I think it's cool, and two, if anyone's headed to IB with me next year, if you're going to take higher level IB, this is something that we study in IB, and we take this farther and so forth. Okay, so here goes nothing. I'm going to see. I wrote this worksheet, but I haven't thought through it. Well, I mean, I thought through it when I wrote it. I haven't answered it. Okay, so they're telling us, I'm telling you, to find this complex number A by multiplying the rectangular form of the two complex numbers. So A is this complex number Z, which was given here, and then W, which is given here, and they want us to multiply these together. So if I have two complex numbers, 3 minus 3i root 3, and I multiply it by negative 2 minus 2i, I'm going to have to FOIL, first, outer, inner, last, or I'm going to have to distribute through. Okay, so 3 times negative 2 is negative 6. 3 times negative 2i is negative 6i. Then I have, what is this? A positive 6. 6i root 3. Okay. Oh, this is going to be annoying, y'all. Okay, and then, so I may not have written a good worksheet. Anyway, this becomes a positive 6i squared root 3. Okay, so what is happening here? We now have, this becomes a real part. So this becomes a minus 6. So our real part is negative 6 minus 6 root 3. This is the A value. And then the B value becomes plus, these two parts are real, or the negative 6 plus 6 root 3 times I. Okay, and so when we multiply those together, that's what we get. Okay, so then I'm asking you to find the polar form of these things. Okay, what happens? So when we have the r is equal to this squared, the square root of this squared plus this squared. I didn't intend for it to be quite this gross. Let's see. Okay, if I'm in my, let's see, if I take negative 6 minus 6 root 3, and I square that, and then I add negative 6 plus 6 root 3, and I, close parentheses, and I square that. Oh, that's nice, actually. The square root of 288 is going to be 12 root 2. Well, isn't that convenient? Okay, so the polar form, sorry, this will kind of make a little bit more sense. The radius here, did you see what I did? I said that the radius is equal to the square root of a squared plus b squared. So then I used a calculator to kind of help me clean up that mess. And then now we're going to find this value is going to be, this is a negative, and then what happens here? I think this becomes a positive, so we should be in quadrant 2. Let's see if I'm right. Negative 6 plus 6 root 3. Well, thanks, calculator. Okay, it is positive, so that's good. So now what I need to do is I have my, to find my inverse, I want arctan, I'm in, nope, I want to be in radians. Shift, setup. Nope, what am I doing? Setup. Nope, that's not what I wanted. Come back. Shift, setup. There we go. Oh my goodness. Jet lag, you guys. I went to the UK. It was great. It was wonderful. Okay, so now I want to do inverse tan of that, the b value over this. So negative 6 plus 6 root 3 over the a value was negative and a negative. So negative 6 minus 6 root 3. Oh, fantastic. But because this is in quadrant 4 and I knew that I wanted it to be in quadrant 2, I have to add pi. 11 pi over 12. Okay, so, oh my goodness. What did we just find? We found, oh, I forgot to write it down. We found that our radius is 12 root 2 and our angle would be, so we can say cis 11 pi over 12. Oh, goodness. Okay. The whole point of this, it's definitely an extension. This is beyond the scope of our course. I do not expect them to ask you to convert between the two, and I don't want you to do it without a calculator. Okay, so now we're gonna put these two, I think, are fair game within the pre-cal world. So they want you to take this coordinate right here and write this in polar form. By they, I mean me. I wanted you to do it. Okay, so where are we? We are at 3 minus, so positive 3, negative 3i root 3. So here's 3. This is 3 root 3 going in the negative direction. I like to put the I in here because then then it doesn't end up looking like negative 3 root 3i, which would be wrong. Don't do that. Do you see what I'm talking about? Okay. So this is a 30, 60, 90. Here's that 60-degree angle. So this is opposite the 30. That means opposite the 90 is going to be 6. So z would be equal to 6 cis 5 pi over 3. Okay, and then w is where? W is in, it was negative 2, negative 2i, so that is here, negative 2, negative 2, and so 2 root 2, and that would be 5 pi over 4. So this w is equal to 2 root 2 cis, what did I just say, 5 pi over 4? Okay, and so here's what's happening with, so notice I have, there's a relationship happening. Notice the 6 and the 2 root 2, and then I had this 12 root 2 from before. What I'm doing is I can multiply the radius out, the r values out front. And then, do you see how that happens? 6 times 2 root 2 is going to give me 12 root 2. And then if I take the angles, well, if I multiply them, that gives me 25 over 12. That's not what I have. And if you think about it, 25 pi, no, if you multiply, you get 25 pi squared. Who knows what pi squared is? That's not what we're doing. But if I get a common denominator, 5 pi over 3 plus 5 pi over 4, I need a denominator of 12. So this becomes, am I right? Yeah, multiply by 4 over 4, this is 20. Plus multiply by 3 over 3, this is 15. Everybody's over 12. Okay, so this is 35 pi over 12. Where in the world is 35 pi over 12? Well, I can subtract away 2 pi, which is 24 pi over 12, which gives me 11 pi over 12. So this value right here, it came to something that's coterminal when I add those two angles right there. So isn't that cool? So basically what's happening is, if I'm going to multiply, the R1 gets multiplied by R2, and then cis value, then the thetas get added together. And in this particular problem, it may not have made life, it probably would have made life easier to go straight to getting these and then multiplying and then adding and then you're done. Okay, so this was that A value, or not A, whatever. It's whatever that new equation is. Okay, here we go. We're gonna keep plugging along. Okay, so they say use binomial expansion to find z to the fourth in rectangular form. So this is saying our z value was this 3 minus 3 root 3i root 3 to the fourth. Okay, so in binomial expansion, remember from Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That's the row that we care about. And so it's 1, and then we have a 3 that gets raised to a power, and then a negative 3i root 3. And so this is raised to the fourth power in the first term, and this is raised to the 0. And then we have plus 4, and then we have 3 raised to the third, and negative 3i root 3 to the first. And this is annoying, and I know it is, and that's why I'm showing you why we care about this. I didn't line up my work properly. To the 1, this is up a negative 3i root 3 to the third, and my last term is plus 1 times 3 to the 0. That's a 0 times negative 3i root 3 to the fourth. Okie dokie. Okay, so this 3 to the fourth is 81, plus now we have 27 times 4, 54, 108, times a negative 3. 108, so negative, you're going to have to let me know if I make mistakes. So minus now a negative 324 I root 3. Ew. Okay. And then this is 9 times, 27 times 6, so 81 times 2, 120, 162. You know what? I have a calculator. There's no reason I can't use it. 6 times 9 times 3 root 3. No. What did I forget? It's 6 times 9 times, and then it's 3 root 3. That whole thing has to get squared. Okay. So, does that make sense? 9 times 3 is 27 times another 9 times 6. Well, what did I say? 9 times 27 times 6. Oh, that's good. That's promising. But, and then it's an I squared. So the negative gets squared, it becomes a positive. The I squared makes it equals negative 1. So this becomes a minus 1458. You guys, I did not write a nice problem. Okay, now we have 4 times 3 times, and then in parentheses here, a negative 3. Well, I'm going to ignore the I for just a second. Well, maybe I won't ignore the I. Shift I. This gets cubed. Did I plug that in correctly? Oh, that's annoying. Okay. This becomes, I don't want that value. Let's take out the I and see if it'll give me the exact value. Nope. Okay. We're going to say 4 times 3 times 3 cubed is 27 times 3. This becomes 3 to the 3 halves power, so it's 3 times root 3. So it's 972 root 3 times I to the third. So that's a negative 972 I root 3. Yes, it would have been positive. No, hang on. We're here. We would have had a negative cubed becomes a negative, an I cubed becomes negative I. So this is a positive. Oh, y'all, I wrote a gross problem, which is also proving my point, but whatever. So then I have, this is 3, negative 3 to the fourth is 81. I to the fourth is positive 1. And then the square root of 3 to the fourth power becomes 3 squared, which is 9. So I have 81 times 9, which 81 times 9, I should know this, but I did know that. Plus 729. Oh, goodness. Okay, so now I have 3 parts that are real and 2 parts that are non-real. And so my real parts were 81 minus 1458 plus 729 is this. I get negative 648. And then I have the non-real negative 324 plus 972. So plus 648 root 3, all of this is multiplied by I. Okay, that's promising that they're the same. Did you know the calculator will do this for you? What did I have? I had 3 minus 3 I root 3, I think. I may have to change my setup. I may have to put this into complex mode. Maybe that is complex mode? No, complex mode. Real, if I go to A plus BI, let's see what that does. Okay, I'm taking this thing and I was raising it to the fourth power. Okay, let's see. This right here, I just said it was that, and they're giving me this decimal. So if I have 648 times root 3, yeah, I know. Oh, is that the same? Oh, that's great news. Okay, so we did this correctly, but it was really annoying. So then it says find the polar. Well, notice here I have negative, positive, and one of them was something right here, negative 648, and then this was a positive 648 root 3. So this is opposite the 60. Here's the 30, there's the 90, and that is an absolute mess. I'm so sorry. So then the opposite, the 90, is going to be twice that big. I'm doing everything wrong today, so I'm going to use a calculator. So 1296 is this value right here. So find the polar form. It's 1296 cis. Well, this is the 60-degree angle, so this is 2 pi over 3. or something coterminal to that. Okay, so then write a general rule. So here, it's kind of hard to see the general rule, but what we did is we knew that z was equal to 6 cis 5 pi over 3, and then we got z to the fourth was equal to 1,296 cis 2 pi over 3. And you're like, how did we get there? Well, check this out. What is 6 to the fourth power? Ha ha ha. Okay, so this is, this was 6 to the fourth, cis. Well, and then this is anything 2 pi over 3 plus 2 pi k. Well, notice what is 5 pi over 3 times 4? Well, 5 pi over 3 times 4 is 20 pi over 3. When I come along and say 20 pi over 3, and then I start subtracting 2 pi, where's pi? Here it is. Look, they're coterminal. That is super cool, yes? So the general rule is, and this is de Moivre's theorem that we teach in IB, is that if I have some complex number in polar form and I want to raise it to the nth power, it ends up being, so r cis theta raised to the n is equal to r to the n times cis of n theta, or theta n. You can write them, they're multiplying right here. Oh, okay, so that's kind of ridiculous. So doing this work is what's ridiculous. And I did it even though it was brutal for you and for me, so that you can see that if I can take this rectangular number, convert it to a polar number, then this formula is a lot easier to work with, which is what I'm going to show you in this problem right here in just a second. But it says use the polar form. Oh, well, I'll do it. I'm doing the same thing twice. Okay, so W, we said W was equal to 2 root 2 cis 5 pi over 4. Okay, and so they want us to find that to the 10th power. So if I take W to the 10th power, what that means I'm going to do is I'm going to take 2 root 2, raise that to the 10th power, and then I'm going to have cis, 10 times 5 pi over 4. 2 to the 10th, 2, 4, 8, 16, 32, I'm still going, 64, 128, 256, 512, 1024. So I think that's 1024. Did I tell you I'm jet lagged? Oh, yes, okay. So this is 1024 times, now root 2 to the 10th ends up being 2 to the 5th. So which was 2, 4, 8, 16, 32. So I have 1024 times 32. Okay, which is this number. Cis, now I need to multiply. Well, this goes in here. I can wait, what am I doing? 50 over 2 is 25. So this is 25 pi over 2. Well, we don't know 25 pi over 2, but I do know that I can subtract away multiples. So I can come here, 25 pi pi over 2, and I can then subtract away 2 pi. This is not the most efficient way to do this, but I am jet lagged. So when I keep going, notice I end up right here at pi over 2. You didn't see what I was doing, but I ended up at pi over 2. So this is coterminal, would also be equivalent to 32768 cis pi over 2. Okay, what does that even mean? That means that we are at this, we have an angle of pi over 2, so we're way up here. So this is just equal to a 32768i. Okay, let's check it with the calculator. What was our W value? Our W value was -2 minus 2i. I'm in that complex mode. Do you remember how we did that before? And now we need to raise this to the 10th power, which was really gross. And we just got the correct answer. Oh, happy day. Oh, happy day. Okay, do you know what? I don't want to. How long have I been talking? Almost 20 minutes? You know what? We can do hard things. Let's do this. I don't have to shy away from difficult things. Neither do you. Do difficult things. Ready? Here we go. So this is negative 2 root 2 and then a positive. I keep putting us in quadrant 2. So a negative 2 root 2, and then notice this 2 root 6 is just a root 3 times that. So I happen to make this a 60-degree angle. I don't know that I intend to do that all over the place. But then this doubled becomes 4 root 2 is my radius. So negative 2 root 2 plus 2, I don't know why I have parentheses, but whatever. This would be equal to 4 root 2 cis 2 pi over 3. Okay, so now they want us to raise this to the 5th power. So 4 root 2 gets raised to the 5th power. Cis of 5 times 2 pi over 3. Okay, 4 to the 5th power. I would keep the numbers reasonable if I didn't give you a calculator. I could have gotten there, but I didn't want to. 2 to the 5th power, or root 2 to the 5th power becomes 2 to the squared times root 2. So 4 root 2, so we have this times 4. So we end up at 4096 root 2 cis of, what the heck is this, 10 pi over 3. Well, 10 pi over 3 is not unit circle friendly, but if I subtract away 6 pi over 3, I'm at 4 pi over 3. So this is would be equivalent to that. Okay, so now if I'm going to expand this out into rectangular form, I have to now say this is 4096 root 2 times cosine of 4 pi over 3 plus I times, 4 times 4 and that times sine of 4 pi over 3. Okay, this we know from the unit circle, 4 pi over 3 is in quadrant 3. The cosine value is negative 1/2. Okay, what is half of 4096 divided by 2? So 2048, oh, the number game that we love. Okay, plus sine of 4 pi over 3 is a negative root 3 over 2. So this becomes, a minus 2048 root 6 times I is what I'm getting. Okay, let's see what happens. If I try and type this into the calculator, can you see most of what I'm doing here? I don't know what you can see. Okay, sorry. So if I'm going to come back and plug this in, negative 2 root 2 plus, plus 2I root 6, close parentheses, raise that to the 5th power, I should get this. Here's the moment of truth. You're about to find out if I know what I'm talking about. No, I don't know what I'm talking about. Dang it, what did I do wrong? I forgot a negative, but that's not even what they have. Oh, I might not be, okay, this is definitely negative. That I messed up on, but I might not be as wrong as I think. Let's see. If I have 2048 times root 2, this matches. Oh, hallelujah. Okay, and then if I have times root 6. Oh, by the way, in London, I got to go see Handel's house. So I just sang a little bit from Handel's Messiah, that Hallelujah course. And I actually got to see where he lived for like 37 years of his life. And did that match what we saw right here? It sure did. So this is why we care. This is a much extended version of why we care about all this. I hope that was helpful. If you made it to this far, comment below and tell me that, tell me your favorite ice cream. Just kidding, I don't know. Subscribe, come back, let me know how I can help you. Good luck, go practice.